Hi everyone. In this video we're going to look at a third method for solving quadratic equations. We've already talked about solving by factoring, solving by square roots, and now we're going to talk about solving by the quadratic formula. So here it is. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. So this gives the solutions for a quadratic equation in standard form, ax squared plus bx plus c equals 0. Alright, so first let's see where this formula comes from. So if we looked at the quadratic equation in vertex form, alright, remember that we can switch back and forth between standard and vertex. So if we're looking at ax squared plus bx plus c equals 0 and we want the solutions of that, there's no problem to look at it in a different form. We also know that we have two formulas for h and k. H is negative b over 2a, and k is c minus ah squared. So first off, let's solve for x from vertex form using square roots, and we've seen how to do this before. Alright, so we would subtract k from both sides and then divide by a. Okay, that's negative k over a. Then we would square root both sides and add in a plus or minus sign. And then we would add h to both sides, and we end up with this equation here. Okay, h plus or minus square root of negative k over a. Alright, so next, if I substitute h and k with the expressions that they equal, alright, so basically I want to write them in terms of a, b, and c, then we end up with, let me erase some of this. Okay, so then x equals, instead of h, I'll write negative b over 2a plus or minus square root of negative, now k is c minus ah squared, right, over a. And now instead of h right here, I'm going to replace that also with negative b over 2a. Okay, so basically I'm just taking the solution to the equation. I have a solution for x, but it's in terms of h and k, and I obtained this using square roots. Alright, and now what I want to do is just simplify until the point where I get this written in a little bit different form. Alright, so let's work on that. So right now I just want to work on simplifying this numerator inside the square root. Alright, so if we square negative b over 2a, alright, that means multiply it by itself, and we end up with positive b squared in the numerator, and then in the denominator we have 4a squared. Okay, 2a times 2a. Next, I want to multiply this by a. So I end up with ab squared over 4a squared. And then I actually have an a in the numerator and denominator that I can cancel. Right, so a squared is a times a, and I can cancel one of those. So this turns out to be b squared over 4a. Alright, so now if I rewrite this, this is negative b over 2a plus or minus square root of negative c plus b squared over 4a, and all of that is divided by a. Okay, so next I want to do the dividing by a. Alright, so I'm going to divide each term. So negative c over a. And then here I have b squared divided by 4a and also divided by another a. Alright, and you may remember that dividing by a is the same as multiplying by 1 over a, multiplying by the reciprocal. Okay, so instead of dividing by a, I can multiply by 1 over a, and that ends up as b squared over 4a squared. Okay, and then the last thing I want to do inside the square root is combine these fractions. So I need a common denominator, and what I need to do is I'm going to make this a 4a squared. All right, so I'm going to multiply this. Let's see, let me erase. Okay, I'm going to multiply negative c over a by 4a over 4a. Okay, so then we end up with 4a times negative c, and that's negative 4ac, and that's all over 4a squared, plus b squared over 4a squared. So now I can add them, they have the same denominator. Okay, and when I add, I'm going to put the b squared in front, so that's going to be b squared minus 4ac over 4a squared. Okay, and that's all going to be inside the square root. Okay, so that's what we have so far. And now I can't square root the numerator here. This is a difference. All right, there's a subtraction sign in there. So I can't do anything with that, but I can square root the denominator. All right, so what's the square root of 4a squared? All right, so in other words, we're asking what times what makes 4a squared, where these two things are the same, and we find that 2a works. That's 2a times 2a. All right, so the square root of 4a squared is just 2a. So I can rewrite this. This is x equals negative b over 2a plus or minus square root b squared minus 4ac, and then that's divided by 2a. Without the square root, I've taken the square root. And then finally, these two things have the same denominator, so I can write this as a single fraction and have everything divided by 2a. And there it is. There's the quadratic formula. Pretty neat. All right, so basically, to summarize, if we were to take this standard form equation and basically just solve using square roots, all right, and I would need to find h and k in the process and write them in terms of a, b, and c, etc. I do a lot of rearranging, a lot of simplifying, and eventually I come up with the quadratic formula. All right, so in other words, we're just doing ahead of time with the formula what you would do normally with numbers in every situation. And then you end up with a formula that you can apply to any problem rather than having to redo all of those steps every single time. So the nice thing about this is that you can use it for any quadratic equation at all. We won't talk about them in this course, but even ones that have imaginary solutions that aren't real can still be handled by this formula. All right, so let's practice. Solve 2x squared minus x minus 8 equals 0 using the quadratic formula. All right, so here it is. I'll recopy it for us. All right, so first step, let's try to identify what a, b, and c are. All right, so a is 2, and I wouldn't hesitate to write these down, even though you can see them in the equation, and that way you just make sure you get the right plus or minus signs on these. So b is negative 1, and c is negative 8. All right, next step is to substitute a, b, and c into the formula. So I have x equals the opposite of b. So b is already a negative 1, so this would be a negative 1. That's a positive 1. Plus or minus square root. All right, b squared. Now this is very important. A lot of people will just write negative 1 squared, and that's actually not correct. We've seen previously negative 1 squared is actually negative 1, okay, because that means a negative, and then the 1 is the only thing that's squared. Right. We actually want to square whatever b is. All right, so if b is negative 1, we want to square that, multiply that times itself. So what we actually want is negative 1 in parentheses. We actually want negative 1 times negative 1, and that's positive 1. So basically, b squared, this should always be a positive number. All right, and hopefully putting in the parentheses, hopefully you'll remember that, and that should help when you're entering it on a calculator. But if you end up with a negative there, then just double check. That should always be a positive number. Okay, enough said about that. Then minus 4 times a, which is 2, times c, which is negative 8. I put parentheses around everything. That way it's clear that this is multiplication, not subtraction. Like it's not a minus 8. We're not subtracting 8, it's times negative 8. All right, and then all of that is divided by 2 times a, which is 2. Okay, next we want to simplify using order of operations. So we treat the square root kind of like a parentheses. If there was anything inside, we would do that first. All right, so we'll do that. And you could just type all of this into a calculator, but if you choose to do it by hand, this is what it would look like. All right, so negative 1 squared is 1. And then I have minus, and I'm just going to treat this like a negative 4 times 2 times negative 8. So I'd have a negative times a negative is going to be a positive, times a positive 2 is still going to be positive. So this is plus, and then 4 times 2 is 8, 8 times 8 is 64. All right, divided by 4. So we end up with 1 plus or minus square root 65 over 4. All right. Now sometimes we're done there, but sometimes if the square root needs to be simplified, then we would keep going. So I do need to check if square root 65 is fully simplified. All right, so to do that, I need to see if there are any perfect squares in 65. All right, so what I'm going to do is factor the 65. All right, I know 5 goes into that, and that's actually 5 times 13. Now, both of those are prime numbers, and neither one is a perfect square. So we can stop there. In other words, the square root of 65 is as fully simplified as it can get. Okay, so this would be your answer. Now, it may not look like it, but this is 2 answers. It's a quadratic equation, so we were expecting 2 values for x. And you can write it just like that, but if you wanted to just observe what the 2 answers are, one of them is a 1 plus square root 65 over 4, and then the other is 1 minus square root 65 over 4. Okay, so we'll do a few more examples, just try to hit all the different types of answers you might see at the end there. All right, so have the formula on hand as we go through. All right, a is 3, b is negative 5, c equals 1. So the formula gives x equals the opposite of b is negative 5. That's going to be positive 5 plus or minus square root of b squared minus 4 times a times c, all over 2 times a. Okay, so simplifying the part inside the square root first. 5 plus or minus square root. Negative 5 squared is 25. All right, and then negative 4 times 3 times 1 is negative 12. Divided by 6. And that's 5 plus or minus square root 13 over 6. All right, 13 is a prime number, so I'm not even going to try to factor that. All right, square roots of anything that's a prime, that's as simplified as it can get. So those are the 2 answers. Okay, 5 plus or minus square root 13 over 6. All right, how about this one? This one's not in standard form, so if you look back at the instructions for the formula, let's see. Okay, these are the formula gives solutions for a quadratic equation in standard form when it's set equal to 0. So that's our first step. We have to set it equal to standard form. All right, set it equal to 0. All right, so what I want to do, I usually like to leave the x squared as a positive number if possible. All right, and it is, so I'm just going to subtract 5 to move it to the right. Okay, so 5x squared plus 8x minus 5 equals 0. And if you forget this step, you're just going to have a, b, and c with possibly the wrong signs, plus or minus signs, something like that. All right, next, substituting into the formula, we have x equals negative b. Okay, b is 8, so a is 5, b is 8, c is negative 5. Right, opposite of b, plus or minus square root of b squared, 8 squared. Now, I don't usually put the parentheses around positive numbers, but you could if you wanted to. Right, minus 4 times a times c, and that's all divided by 2 times a. Okay, so simplifying inside the square root, 8 squared is 64, and then negative 4 times positive 5 times negative 5 is going to be a positive number. 4 times 5 is 20, 20 times 5 is 100, and that's divided by 10. Okay, so we have negative 8 plus or minus square root of 164 divided by 10. Now I do need to work on simplifying the square root. What is the square root of 164? All right, so let's factor 164. And let's see, I do know that 2 goes into this. This is 2 times 82. 82 is 2 times 41. And 41 is a prime number. All right, so simplifying square roots, all right, we'll review that. Anytime you have prime factors that come in pairs, that's an indication that we have a perfect square. Right? So in other words, square root 164 can be written square root of 2 times 2 is 4, and then times 41. All right, so you can double check that. That does equal 164. Now square roots, we can split this up and write square root 4 times square root 41. Okay, and square root of 4 is 2. So this is 2 times the square root 41. Okay, so back to my quadratic equation. Now I can write this as negative 8 plus or minus 2 square root 41 all divided by 10. All right, and we're almost done. The last thing to check, this is not considered fully simplified because there is something that can be divided evenly into negative 8, 2, and 10. All right, if it can be divided into all 3 numbers, then you would keep going. So all of those can be divided by 2. So I would do that and get x equals negative 4 plus or minus 1 square root 41 and divided by 5. Okay, and then that's fully simplified. All right, this one. This is almost standard form, but I need to subtract 1. 3x squared minus 3x minus 1 equals 0. Okay, substituting a, b, and c. So a is 3, b is negative 3, c is negative 1. So we have x equals the opposite of b plus or minus square root b squared minus 4 times a times c all over 2 times a. And we get 3 plus or minus square root 9. And then negative 4 times 3 times negative 1 is plus 12, all divided by 6. Okay, so that's x equals 3 plus or minus square root 9 and 12 is 21 divided by 6. And 21 is 3 times 7. Those are both primes, and neither is a perfect square, so that can't be simplified. And we would leave the answer like that. Right. Now, notice in this one, it's tempting to try to reduce the 3 and the 6 to 1/2, but because we didn't have a number outside the square root of 21, we can't do that. Right. So the only time you can reduce, it's using the identity property, right, and the distributive property. So in order to make this 1/2, what I'd have to do is factor a 3 out of the numerator. And if that was the case, then I could factor a 3 out of the denominator and then reduce 3 over 3 to 1. Okay, so I don't have that in this case. All right, so that's the answer. However, if you had 3 plus or minus 3 square root 21 over 6, then we could reduce this. All right, so I would factor a 3 out of the numerator, and this would be 1 plus or minus square root 21. And then I would factor 3 out of the denominator, and that would then be a 2. And then now I know that 3 over 3 is 1. All right. The only other thing you can do with this, 3 plus square root 21 over 6, some people like to split this up into 2 fractions. So you could make this x equals 3/6 plus or minus square root 21 over 6, and then you're allowed to simplify this fraction, 3/6. So I could write 1/2 plus or minus square root 21 over 6, and that's also correct as well. Okay, we'll do one more example. So in this case, I will subtract x from both sides to get this in standard form. X squared minus x minus 13 equals 0. So then a is 1, b is -1, c is -13. So we have x equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. All right, so that's 1 plus or minus square root. This is going to be a 1. -4 times 1 times -13, that's a positive 52, all divided by 2. And this is 1 plus or minus square root 53 over 2. And 53 is a prime number, so that can't be simplified anymore. And there's no reducing to do because I've got a 1 here and a 1 outside of the square root 53, so that's how I would leave the answer. Okay, that's it. So we talked about how we get the quadratic formula just based on solving by square roots and rearranging things, and then looked at some different examples of using the formula to solve different quadratic equations.